Manufacturing. The primary concern of this chapter is to explain the logistical implications of decisions related to manufacturing processes and strategies. Dimensions of product quality. Quality is not as simple as it may first appear. The term quality may mean different things to different people. Quality is traditionally viewed in terms of 8 different competitive dimensions. Performance. Perhaps the most obvious aspect of quality from a customer's viewpoint is performance, or how well the product actually performs in comparison to how it was designed to perform. Superior performance in a product is generally an objective attribute which can be compared between items and brands. Reliability. Reliability refers to the likelihood that a product will perform throughout its expected life. It is also concerned with the number of breakdowns or repairs that a customer experiences after purchase. Like performance, reliability is a characteristic of quality that can be objectively measured. Durability. Durability refers to the actual life expectancy of a product. Of course, lifespan may be extended through repair or preventive maintenance. Thus, durability and reliability are distinct but interrelated aspects of quality. Conformance. Conformance refers to whether a firm's products actually meet the precise descriptions or specifications as designed. It is measured by looking at an organization's scrap, rework, or rate of defects. Conformance quality measurement is usually internal in an organization. Features. Customers frequently judge quality of specific products on the basis of the number of functions or tasks that they perform independently, or reliability or durability. In general, the more features a product contains, the greater is the likelihood that another quality attribute may be lacking, such as reliability. Aesthetics. Aesthetics, the style, materials, and visual appeal of a product is used by many consumers to judge quality. Product designs that are unique or innovative are frequently regarded by customers to be higher quality. Serviceability. Serviceability, the ease of fixing or repairing a product that fails, is an important aspect of quality for some customers. Ideally, serviceability would allow the customer to fix the product with little or no cost or time lost. In the absence of such serviceability, customers generally consider those items or brands that can be repaired quickest at least cost to have superior quality. Perceived quality. Perceived quality is based on customers' experience before, during, and after they purchase a product. Total product quality is a combination of the 8 dimensions, how they are blended by an organization, and how that blend is perceived by the customer. Total quality management. Total Quality Management, or TQM, is a philosophy supported by a managerial system focused on meeting customer expectations with respect to all the needs from all departments or functions of an organization, whether the customer is internal or external, a supply chain partner, or a consumer. A focus on TQM also requires understanding of all quality-related costs. There are 4 types of costs associated with quality management processes. Appraisal costs result from inspections used to access quality levels. Internal failure costs result from quality failures that are found prior to shipment to customers. External failure costs result from failures that are identified only after products reach customers. Prevention costs result from efforts to prevent failures and from efforts to reduce both failure and appraisal cost. Quality standards. Establishing global quality standards is extremely difficult as a result of different circumstances, practices, and procedures around the world. Nevertheless, a set of standards has emerged from the International Organizations for Standardization, or ISO, and has gained worldwide acceptance. Most major countries today have accepted the ISO standards, and, in many instances, companies will not purchase from a supplier who has not received ISO certification. Manufacturing perspectives. The range of products a firm manufactures is based on its technological capability and marketing strategy. Firms perfect manufacturing competencies based on market opportunity and willingness to take the innovative risk. A firm's manufacturing competency is based on brand power, volume, variety, constraints, and lead time requirements. Brand power, the measure of a customer's purchase preference based on a manufacturer's reputation, product quality, and supply chain capabilities, is known as brand power. The power to determine the range of value-added services, physical product movement requirements, timing, and characteristics of flow along the supply chain is directly related to brand power. Volume. Manufacturing processes can be classified in terms of the relationship of cost per unit to volume or output. The traditional perspective is to treat volume in terms of the well-established principle of economy of scale. Economy of scale is extremely important when high fixed cost machinery is used to convert raw material into finished products. Variety. Variety refers to the range of product variations that are capable of being manufactured by using a given process. In terms of logistical support, high variety translates to relatively small manufacturing lot sizes, flexible material requirements, and a broad range of product outputs. Lead time. Manufacturing lead time is a measure of the elapsed time between release of a work order to the shop floor and the completion of all work necessary to achieve ready-to-ship product status. Any given manufacturing process consumes operational and in-operational time. Constraints. Constraints interact with volume and variety to create realistic manufacturing plans. The three primary constraints that influence manufacturing operations are capacity, equipment, and setup or changeover. Capacity is the measure of how much product can be produced per unit of time. Equipment constraints are related to flexibility concerning the use and sequencing of specific machines to perform multiple manufacturing tasks. Setup or changeover constraints are directly related to the need for variety. Basic manufacturing processes. There are four basic manufacturing processes structures that differ in terms of their appropriate use for meeting a firm's production requirements, related to the volume of output required and the variety of products that can easily be accommodated by the process structure. Job shop process. A job shop process provides high flexibility to produce a variety of different products but in limited volumes. Another characteristic of a job shop is that the arrangement of the equipment and therefore the flow of materials tends to be organized around common processing characteristics rather than the given product. Batch process. A batch process is essentially a higher volume job shop in which the same or similar products are produced repetitively. Batch process works well when there is a high variety of different products but each has a relatively low volume. Line flow process. Line flow processes can produce high volumes of relatively standardized products. The workflow is organized around a single product. Steps are arranged in sequence and broken up into the smallest steps possible. Continuous process. Continuous processes are used for high volume products where the demand for the product is very large and can justify the capital investment necessary. The processes are very flexible in that they cannot easily be adapted to produce a different item. Matching manufacturing strategy to market requirement. A firm's strategic marketing posture concerning flexibility and agility to accommodate specific customer requirements is directly related to manufacturing capability. To a significant degree, a firm's manufacturing capability drives the feasible range of effective marketing strategy. For a manufacturing firm to effectively compete, it must be able to integrate manufacturing capability into a meaningful marketing value proposition. Alternative manufacturing strategies. There are four common manufacturing strategies that are typically employed by organizations. The strategies differ in their ability to meet customer requirements, and the choice of manufacturing strategy impacts the total order to delivery time that customers experience. The four strategies are engineer to order or ETO, make to order or MTO, assemble to order or ATO, and make to plan MTP, and is also referred to as make to stock or MTS. Engineer to order. In an ETO strategy, products are unique and extensively customized for specific needs of individual customers. ETO products utilize a job shop production process. The customer who desires a custom-designed product from an ETO manufacturer experiences a very long order to deliver time. Make to order. Manufacturing of MTO items closely resembles that of ETO items in that a customer order triggers activities at the very beginning of the process. However, MTO strategies differ from ETO in that customers typically order from standardized product designs that may be somewhat customized to meet a specific customer need. Assemble to order. An ATO strategy, base product components are manufactured in anticipation of future customer orders. However, no finished product is created until a customer places an order. It has the potential to combine the facets of economy scale provided by line flow processes with a degree of flexibility characteristic of job shop or batch processes. Make to plan. MTP strategies are characteristic of companies exploiting economy of scale gain from long production runs utilizing line or continuous flow processes. Totally dependent on a forecast of customer demand, significant finished goods inventory is typically manufactured in anticipation of future customer orders. Total cost of manufacturing. TCM consists of production or procurement, inventory or warehousing, and transportation. The TCM results from functional integration of manufacturing, procurement, and logistics. From a perspective of integrated management, it is important for manufacturing firms to design a supply chain strategy that achieves lowest total cost of manufacturing across the entire process. Mass customization. The desire on the part of many manufacturers is to get the cost advantages of high volume, continuous, and line flow processes while increasing variety for customers. Accomplishing this objective is known as mass customization. Lean systems. Lean is a philosophy of manufacturing that emphasizes the minimization of the amount of all the resources used in the operations of a company. Operational processes are considered to be lean when they are very efficient and have few wasted resources. Flexible manufacturing. Flexible manufacturing systems have sometimes been considered inconsistent with the principles of lean systems. Typically, flexible manufacturing implementation involves modification of basic line flow processes. Six Sigma. In a Six Sigma approach, the goal is to achieve a process standard deviation that is 6 times smaller than the range of outputs allowed by the product's design specification. A primary objective of Six Sigma programs is to design and improve products and processes so that variability is reduced. The Six Sigma approach is actually a structured process for first identifying resources of variability and then reducing them. Requirements planning. In complex manufacturing organizations, a process known as materials requirements planning or MRP is frequently used to aid in the interface between purchaser and supplier. Implementation of MRP systems requires a high level of technological sophistication. Design for manufacture. DFM is an umbrella term that describes a set of methods and tools that focus design activities on improving product manufacturability. DFM involves design review meetings between product engineers and manufacturing personnel. DFM efforts have been credited with improving the quality of products while saving firms thousands or even millions of dollars. Design for logistics. Just as DFM represents a recent development in manufacturing, the logistics interface with other functional areas can be greatly enhanced by incorporating concept known as design for logistics into the early phases of product design. In particular, product packaging and transportation requirements need to be incorporated into the design process.